Binary in everyday use. In our previous tutorial, we spoke about how binary, a language that is composed of just zeros and ones, is the only language that computers understand directly. We spoke about how the computer's memory is composed of tiny segments which can each individually be set to either this or that value. And as a result, because these tiny segments, which are the building block of a computer's memory, whether it be its small-term memory or its long-term memory or whatever form of memory, since it is composed of these tiny segments which can be set to either one of two values, this is the reason why then the computer or binary is then the best system or language that best maps to the computer's physical components. So for this reason, this is why we speak about the computer using ones and zeros. So what we're going to do today is we're going to see how we have been actually, perhaps without even realizing it, referencing these ones and zeros, or these bits. As we said in our previous lesson, each one or zero is called a bit. So we're going to see how we have been referencing these, or how we actually reference these bits in our day-to-day talk as far as computers are concerned. We'll look at two such examples. Our first example will be computer storage. Now, whether the storage be in the form of a flash stick or flash drive, the computer's internal hard drive, or an external hard drive, we have often asked or have wanted to know, how big is it? And the answer that we've either given ourselves or we have received for this question, it would be something like, for the flash drive, it's 8 gigabytes, or something like 500 gigabytes for the computer's internal storage or hard drive, or something like 1 terabyte. But the question is, what does this mean? Like, what do we mean when we say 8 gigabytes or 500 gigabytes or 1 terabyte? And what does that have to do with those tiny bits or those zeros and ones? So let's dive into bits and see how, when we're speaking about 8 gigabytes or 1 terabyte or whatever the case may be, we are actually referencing bits, and we're speaking about how many bits are there. So let's look a little bit closer to bits and see what they have to do with bytes and gigabytes and terabytes, etc. So we spoke about how the building blocks of a computer's memory consists of tiny units, which can be this or that, or in other words, which can be either a 1 or a 0. So as a result, the building blocks of the computer consists of these tiny units. A single one of these units is called a bit. So that's a single binary digit, which is actually a representation of that single unit in the computer's memory, that smallest unit. Now, when you group 4 bits together, what you get is what is called a nibble. This is not actually something that many people are familiar with. Now, when you group bits into groups of 8, you get what we call a byte. Aha! That should be a light bulb moment, as this is what we're most familiar with, the word byte. So what a byte is, it's actually 8 bits grouped together. So 1 byte is 8 bits, 2 bytes is 16 bits, etc. But a computer has many bytes. So if we kept on referring to the memory in terms of bytes, we would end up having to speak about thousands of bytes, and then millions of bytes, and then billions of bytes. So to avoid this, 1000 bytes are called 1 kilobyte, in the same way that when we're dealing with meters, for instance, in terms of distance, once you hit 1000 meters, you say 1 kilometer instead of 1000 meters and 2000 meters. So in like manner, 1000 bytes is 1 kilobyte. Now, when you start dealing with even more amount of memory or more bytes, and you start getting into 1000 kilobyte regions, we then say 1 kilobyte we then say 1000 kilobytes is 1 megabyte. In like manner, 1000 megabytes is then 1 gigabyte, and then 1000 gigabytes is 1 terabyte, etc. So let's go back to our example of storage. Let's take the 8 gigabyte flash. So when we say a flash stick is 8 gigabytes, we're actually saying it's approximately 8000 megabytes. which is approximately 8 million kilobytes, which in turn is approximately 8 billion bytes, which is approximately 64 billion bits or 64 billion zeros and ones. Let that sink in. That small flash actually has 64 approximately. When we say it's 8 gigabytes, there's even 16 gigabyte flash sticks. But for just taking the 8 gigabyte one, it has approximately 64 billion tiny memory cells in that small space, which is about the size of your small finger. So let's look at our second example of how we reference or we refer to bits in everyday talk. Consider files and their sizes, whether it be text files, images, or videos. We often check how big a file is. For instance, your typical text file will be something like 4 kilobytes. Your image anywhere between 100 kilobytes to a few megabytes. Then your video can be a couple of megabytes up to 100 megabytes, 700 megabytes. Some are even gigabytes. When we speak about file sizes, it's similar to the concept of us speaking about the capacity or the size of a device or a storage device. Let's take, for example, the 100 megabyte video. When we say the video is 100 megabytes, that is approximately 100,000 kilobytes, which is approximately 100 million bytes, which is 800 million bits or 800 million zeros and ones. And that brings us to our end of today's lesson. As we can see, we have been referencing bits or binary in our everyday use of computers. When we speak, for instance, of the memory capacity of our storage devices, whether it be flash drives or internal hard drive or external hard drives, or even as we reference files such as images, videos, and text files, when we speak about their sizes, such as when we say that a text file is 4 kilobytes, so a video is 1.5 gigabytes. We are referencing the bits that it takes to store that particular file. If there's anything that was not clear in today's lesson, don't forget to leave a comment in the comment section. Ask your questions so that we can come back to whatever is not clear and clarify it. Okay, over and out. And oh, don't forget to like, subscribe, and turn on notifications so that you don't miss any subsequent tutorials. Later.